Okay, so to get started, let's look at the initial harness we have here. In our main, we jump to init. In init, we have some commented out code here relating to detours. We'll actually circle back to this later to look at why this is here and how we can use it. But moving on, we can see that we load the DLL. And in this case, I'm actually going to change this to Windows System 32. So we load the RevT service DLL and we load it into hmod. Hmod is actually going to be the base address of this DLL. That's why down here, we can just add an offset to the base address and cast it to a function pointer. In here, I've named the function pointer underscore getLogObject as the type. If we go to that type, I can see I defined it as returning a void pointer and having one argument that is a void pointer. Now, let's look at our reverse engineering session. In this case, I decided to change it to IDA for something different. And let me just quickly up the font. Okay. Now, in our event service object, getLog object, we know that the first parameter was this pointer, and it was initialized by calling the constructor with a buffer of size 0x1a0. So we know that the first value has to be passed to, well, first of all, it's got to be allocated of at least 0x1a0 size. So you know what? Let's go down here, and I'm just going to do this all in this init function for now and split it off into sub-functions later. I'm going to say car pointer p event service object equals to car pointer calloc1 0x1a0 because that was the size we found. And now I need to do something like f event service constructor, pass it p event service object, and that's it. So I need to define f service constructor. Now I'm going to do that something like get log object, but I'm going to replace f get log object with f get service constructor and underscore get log object with underscore event service constructor. And I need to type def that as well. In this case, let's look at event service constructor, which is just event service : event service. We can see here it takes one parameter, which is going to be the buffer that it initializes, and it returns nothing. That's fine. So that's going to be void because it returns nothing. It's going to be fast call pointer. I'm going to call it underscore event service constructor. It takes one argument, which is just a pointer to the event service object buffer. And I'm just going to add a comment here that the buffer is of size 0x1a0. Let me confirm that. Let's see where this is cross-referenced. It's called in global initialize. Passes v0. v0. Okay. So I'm analyzing a slightly different version than what I initially started with. I will provide this version. In this version, the size of the buffer is 0xA8. And that's something to keep an eye out if something updates. Sometimes an update will change things like this, but it can also change function prototypes and more drastic things as well. In this case, the buffer size that goes to the constructor is of size 0xA8. So I'm going to update my sizes to 0xA8. And I'm going to update my calloc to 0xA8. Okay. Now I need to create the correct offsets. Now, in this case, if I go to the event service constructor, I see the address of it is 180055B09. Now, typically, the offset is going to be the last X digits before the zeros. But you can also calculate it by finding the base address of the loaded program. In IDA, you can go to Edit, Segments, Rebase Program, and then copy the value that's there already. And in Gidra, you can go to, I think it's Window, Memory Map, and then find the start address of the headers section. And in Binary Ninja, you can go to like View Triage or something, and it'll have the base address there as well. And what you want to do is you want to do the address of the function minus the base address. Make sure you have 0x in there so it knows it's all hex. Okay. So I'll copy this into a notepad file just so I can zoom in on it. So this is what I did in the Python console. I grabbed the address of the event service constructor and I minused it by the base address. And that gave me this 0x55b09 value. And that's the offset. I can grab that offset and add that here. So now that's the event service constructor done. Now I do the exact same thing for getLogObject. In this case, it's A6314. Done. Now at this point, we've got the pointer to getLogObject, we've got the pointer to the constructor, and we've allocated the first parameter and constructed it. So now we can do the second parameter, which is just a uint64 pointer. So I'm just going to define a uint64. I'm going to call this out and just initialize it to 0. And then the third parameter was the file path. So I'm just going to create that now. I'm going to put it in C drive, users, user1, desktop, myevtx.evtx. Okay. Now at this point, we have parameter 1, parameter 2, and parameter 3. So I should be able to call fGetLogObject, pass it parameter 1, pass it the address of the out variable, which will be parameter 2, and pass it parameter 3, which is fpath. Now I think this is because I didn't define it correctly up here. Yeah, see up here, it's still left as expecting one argument. In this case, the first argument, I'm just going to say it's a par argument, and that is a event service object pointer. The second one can be a uint64 pointer called pout, and the third one is a wpar underscore t pointer fpath. Now I'm going to say that this returns a uint64 pointer. Okay. And at this point, I should also be able to do printf and do getLogObject results. Let's print it off as hex and print out the contents of out. Because as we saw when we were reverse engineering the target, the second parameter will either be 0 if it didn't succeed, or if it did succeed, then it will be non-zero. And it should be a pointer. So by printing out the out file, the out variable, I'll be able to see if this worked or not. Now I'm going to compile it. Going to grab the compiled binary and the PDB, and I'm going to throw it in my VM. And I'm going to run it. And in this case, I'm getting an error. The get last error is 126. Now, to find out where this error comes from, actually, I wonder if this error comes from loading the DLL. Let's see. Ah, yes. This should be a double slash here. So I was missing a slash, so it wasn't properly loading the DLL. I'm going to go here, loaded revt service, just so I know I've made it past there. Let's give that another go. Okay, it loaded it, and proc1 actually shows the 8-byte read happening, where it went from event log fuzz to start, to get log object, to determine file type, to read file. So we made it that far, but we're not hitting the other 128-byte read. And in fact, our harness is crashing here. You can see that it didn't print out the result because it actually ended up crashing. Now at this point, we have to analyze what went wrong. To do that, I'm actually going to launch Rinderbug, which I have here, and I'm going to run my harness under Rinderbug. We can see it hit kernel base raise exception, which means a C++ exception was most likely encountered. I'm going to press K to dump the stack, and I see that the exception was thrown in event service : open external log plus 0xde. That's pretty soon after open external log. So I'm going to go to my IDA window. I'm going to open external log. And let me just take a quick glance at any throw exceptions. Well, there's a throw exception right here, and it most likely is this one. Now, how do we get to this path? Well, if I look above, this path comes if v6 is non-zero. So if v6 is non-zero, it'll go down this block and throw an exception. v6 is the result of a call to RPC impersonate client. Now remember, this function is expecting to be called via RPC, except in our case, we're not calling it via RPC. We are loading the DLL and calling getLogObject directly, not via RPC. So because we're operating in that different environment, it's quite likely that the results of this RPC impersonate client call are not what the function is expecting here. And that's causing an error. So we're going to have to handle this. And the way that we're going to handle this is by hooking. Now you could do like binary patching, patch this out in the binary and fuzz the modified binary, but I prefer hooking in memory because it's a lot more flexible. And what we're going to do is we're going to hook RPC impersonate client and make sure that it always returns 0. So we skip past this because RPC impersonate client does not matter for our fuzz case. So we can happily hook it and force it to always return 0. And this hooking method to knock out things that get in the way of our fuzzing can be useful for other things as well. Say that every time we were fuzzing, there was a piece of code here that did a pop-up box. And in order to move on to the next fuzz case, we have to keep closing that pop-up box. In that case, that would get in the way of our fuzzing. So what I would do there is I would use hooks to hook that pop-up box code and skip over it. Make sure it does nothing and it doesn't give a pop-up box anymore. That's a similar situation where you may need hooks. And in order to do this, we're going to use Microsoft Detours. So I provided Microsoft Detours as a file, but you can also search for Detours on GitHub and it'll be there. You can clone it and build it as per the README. Since we are fuzzing a 64-bit target, you have to make sure that everything's targeting 64-bit. Your project is targeting 64-bit, And when you use detours, you import the 64-bit detours. So to do that, you go project and your project properties, you go linker and input. And under the input, you browse to detours.lib that lives in the lib.x64 of detours. So it looks like this. This is the library I'm importing. I've got detours in D drive code, and after compiling it, you should have a lib.x64 folder that contains detours.lib. You want to import that in your project under linker, input, additional dependencies. And then at the top of your project, you want to have this includes line that points to detours.h in the includes folder of detours. I'm going to adjust this to be code detours include detours.h. And then in init, I can remove the comments. And to do hooks, first you have to do detour transaction begin and detour update thread. Now, really, you should be doing detour update thread for each thread that exists in your process. This is a single threaded process right now, so just get current thread works fine. Then you want to set our hook, where you define a function prototype a little bit differently than the ones we've done before. I have an example here of fclose handle, where it returns a ball. It's a RIN API pointer. It takes one parameter called a handle. And I named that fclose handle. And then I have my own close handle function here that has the same function prototype. And this is what our hooked version is going to do. In this case, it just calls the original close handle. So by calling fclose handle with a parameter, this is actually going to be calling the Windows API fclose handle, the original one that we've hooked. But I don't have to call that. I can do whatever I want. I can just arbitrarily return 1 if I wanted to, and that would work as well. So now that we have the definition of something to hook, and we have our own custom version that we're going to replace the target with, and we have a way of calling the original function if we like, we can apply the hook. And you apply the hook this way, by initializing fclose handle in this case, and by defining the function signature, whereas it returns a ball through an API pointer and it takes a handle, and I've got to give it the address. In this case, I'm getting the address of close handle from kernelbase.dll using a combination of load library and get proc address. And then finally, I do the hooking by doing detour attach, and this kind of thing with fclose handle and myclose handle. And then I commit the hooks with detour transaction commit. And after all that's done, the hooks are applied, we can move on to the fuzzing. Now in our case, we want to hook RPC impersonate client. Now where does that live? This lives, if I look in IDA's imports, I search for RPC impersonate client, I see it lives in RPC RT4. Likewise, if I typed it on msdn RPC impersonate client, I look at probably the first result. It tells me RPC impersonate client, and when I scroll down, it tells me it's in rpcrt4.lib and rpcrt4.dll. So that matches. An RPC impersonate client on MSDN says that it takes one parameter, which is a RPC binding handle, and it returns an RPC status. I could go further to find out what these actually are, but it's actually enough for me to just see that it's called with a 64-bit value and that it returns a 32-bit value in this case. So that's easy. I'm actually going to define it up here as returning I could do a 32-bit value. Yeah, I'll do a 32-bit value. I'll do uint32. It's a Win API pointer called f_rpc impersonate client. It takes a uint64 arg1, and that's a good enough definition. It matches the sizes we've seen. Now I can create my own custom function. I'm going to name it uint32. It returns the Win API, and it's called my RPC impersonate client. It takes a uint64 arg1, and all it does is return 0. Because we saw that as long as we return 0, it won't go down the path of throwing an exception. So this should be good enough. Now I need to apply the hook. I'm just going to copy the close handle version, and I'm going to just modify what I need to. So f_rpc impersonate client. Instead of bool, it returns a uint32. Instead of taking a handle, it takes a uint64. Instead of being in kernel base, it's in rpcrt4.dll, and it's called rpc impersonate client. Likewise, I could actually remove all of this and give it like an address like we were giving before, either a hard-coded address or the whole hmod plus offset thing. But in this case, we're hooking something from a Windows DLL that's exported, so we can do things this way. And then detour attach, I have to update. That should be good. Now we're hooking close handle, which we really don't need. I could just remove it, but the hook doesn't do anything. It just returns the original results of close handle anyway. So that doesn't matter. RPC impersonate client though, we need, and that's going to pass it to our custom RPC impersonate client function. That's just going to always return 0. Now let's compile this. This is compiled. Let's grab the code. Let's chuck it in here. And now last time we ran it, it hanged. It had loaded the DLL and then it didn't get any, it wasn't able to finish going through getLog object. It went as far as determine file type to get the first 8-byte read, but it didn't get the 128-byte read because it threw an exception before then. Let's see what happens now. Okay, it actually returned a proper result, and we can see now the 128-byte read. And this 128-byte read is happening under get open external log. So now we've done that much. We've actually been able to interact with the getLog object function directly. We've written code that can call the function directly with the right parameters, get a non-zero return code, which means it was successful in this case, and we can see in procmon that we were hitting the 8-byte read and the 128-byte read now. So that's a success. We were able to call getLog object. Now, the next step we may want to do is look into fuzzing the other components. There was, after this 128-byte read, there were other reads that were happening, and including a much larger read, but they were happening in different functions. So there's two ways we can go about it. Again, we can include those function calls and just append that out to the end, to like after we call getLog object, or we could find a higher level outer function call and use that instead. But for now, what we're going to do is we're going to make sure that we can fuzz this function directly. So we're going to have a fuzz loop that it can be file based and just affect fpath, and we're going to fuzz this getLog object function. which means we'll be fuzzing the 8-byte read and the 128-byte read. Now, mind you, when it comes to fuzzing these things, just because the target reads 128 bytes doesn't actually mean it passes it at that point. It could read the bytes into a large buffer, and then it won't actually pass that buffer until we do another function call or something along those lines. But that just takes reverse engineering effort to find out. In our case, we know that in the first 8 bytes are checked at the least. So by fuzzing this function with like winAFL, we should be able to generate inputs that hit different paths, right? It should hit the EVTX file path, the ETL log file path, and the other one, was it a legacy log file or something similar path? Either way, we should be finding new paths and potentially bugs. So now we need to think about what could go wrong when we're fuzzing this. And you could be proactive and reverse engineer the targets we're hitting to see if there's any globals or anything that we may have to take into consideration. One thing that stands out is the fact that we're using this object. This object was constructed via the event service constructor, and we're passing it to getLogObject. Now it's possible that getLogObject changes something in this object, such that if we go to call getLogObject multiple times in a row, which will happen in our fuzz session, that it actually won't be deterministic and something will be different in subsequent executions. One way we can get through that is getting the destructor for event service constructor, or for the event service object, and just doing something like destruct the object. And then in your fuzz loop, you construct it, fuzz, destruct it, construct it, fuzz, destruct it, that type of thing. But your challenge now that we have the ability to call this getLogObject function, is to get it fuzzing with winAFL like we did with GDI+. You'll have to split off some things. So for example, this init function where I've put all the code in shouldn't be the function you define as a fuzz function for winAFL, because this is doing hooks. And there's no reason to do the hooks every fuzz case, right? The hooks should be done once on process start, and that's it. Same with the load library. Our fuzz loop just literally needs to call getLogObject with the constructed parameters. And maybe if our stability is low, think about constructing and destructing the event service object in that fuzz loop. So feel free now to play around with that and see if you can get this target fuzzing in winAFL. Another thing I'll mention is that because the target revtservice.dll is expected to run in a process that actually doesn't run at our current user level, it runs as either local service or something similar. It may actually try to access things during its fuzz case that our regular user does not have access to. If you have issues with something like that, try running your fuzzing harness or your fuzzing session as administrator. And these things can happen because if revtservice is expecting to run in a process that runs as local system, it may try to do things on the assumption that it's system. Like it might try to read specific registry keys that regular users cannot read. In which case, if we go to fuzz or run our harness as our regular user, the target may go to access that sensitive registry key path and it will fail. And that may cause the target to crash. But that crash wouldn't happen on the actual real process because it would actually be running at its expected privilege level, which could be higher, could be local system instead of our user. So sometimes you need to run your fuzz session or your harness as administrator to get around that. So again, try to get this fuzzing, this getLogObject function, now that we have it defined and we can call it, try to get it fuzzing in WinAFL. Once you've tried that, take a look at the solution and we can move on to the next steps.